Volcanoes. They're indifferent monsters. They can level entire cities in a matter of minutes. They unleash all the fury of the earth in one giant burst.
Don't look back!
In the Northwest, we all live just miles away from a number of active volcanoes. At any moment, they're poised to set off major disasters. You're watching Volcano Alert on Northwest Time Bomb.
Hello everyone, I'm Mike Clay. It's a threat many of us live with every day, but we don't spend much time thinking about it. It's the threat of a volcano erupting here in the Northwest, setting off a major landslide or a flood. It's a danger that's increasing because of our booming population. In the next half hour, we'll tell you what you need to know about volcanoes and the effect they could have on all of our lives in the Northwest.
May 18th, 1980. The day all of us in the Northwest got a first-hand lesson in the power of volcanoes. A blast rips open the side of Mount St. Helens. A mudslide gushes down the Toutle River, sweeping away trees and homes. A cloud of ash turns day into night east of the mountain. 57 people die. Mount St. Helens is still active today, but it's only one of many dangerous volcanoes in our region.
I think the message is clear that the volcanoes in the Cascade Range are they're potentially active at any point. There are a dozen volcanoes in Washington, Oregon, and Northern California, any one of which could begin erupting or begin precursors to eruptions starting tomorrow.
The volcanoes we're talking about include majestic Mount Rainier, about 60 miles southeast of Seattle, Washington's Glacier Peak, Mount Baker, Mount Adams, Oregon's Mount Hood, east of Portland, the Three Sisters area in central Oregon, the Northern California peaks of Mount Shasta, Lassen Peak, and Medicine Lake Volcano, and Mount St. Helens. The volcanoes of the Northwest are part of a group of ferocious volcanoes along the Pacific Rim.
The Pacific Ring of Fire is the most active series of volcanic arcs or volcanoes on Earth.
These volcanoes are highly explosive, producing columns of volcanic ash and avalanches of hot rock. How these volcanoes are formed is actually fairly simple. The outer part of the Earth consists of a layer of rock called the lithosphere. The lithosphere is divided into about a dozen large plates. The plates are constantly moving relative to one another. When one plate slides under another, the downgoing plate reaches a level in the crust where it begins to melt. The molten rock, or magma, rises toward the surface of the Earth, where it bursts out, forming volcanoes. This process, called subduction, forms the chain of volcanoes we know as the Cascade Range. Geologists estimate the range has been active for about 36 million years. It stretches more than 1,000 miles, from Lassen Peak in Northern California to Mount Garibaldi in British Columbia.
The Cascade Peaks serve as a great source of inspiration and beauty. They're one of the reasons why we love living in the Northwest. But these old volcanoes could be the future source of a major disaster.
At the top of the hazard list, Mount Rainier, the tallest Cascade Peak. It stands over 14,000 feet high. We're looking at two different disaster scenarios here. The first is a magmatic eruption, like the one at Mount St. Helens. If this happened at Mount Rainier today, would it be anything like the 1980 eruption? The answer lies in the geologic difference between the two volcanoes.
The magmas at Mount St. Helens tend to be more viscous and more explosive. Mount Rainier has a tendency to erupt smaller volumes of ash and coarser material into the atmosphere, more lava flows, and less viscous kinds of lavas or magmas.
So, while an eruption at Mount Rainier is likely to be less explosive than at Mount St. Helens, the danger from mudflows, known as lahars, is much greater. Volcanic activity could melt the huge glaciers covering the mountain and send mud and debris sliding into the valleys below, valleys where people live.
At Mount Rainier, we have not just a few tens of thousands of people, but we have hundreds of thousands of people who are living on deposits from relatively young eruptions and young events at Mount Rainier.
There is a hopeful side to all this, though. We should have at least some warning of an imminent eruption. Monitoring systems should give scientists enough clues to determine if the mountain is going to erupt. The second disaster scenario is, in many ways, much more frightening.
Because Mount Rainier is such a big volcano, it has so much mass, and because it is weakened by alteration in the interior, it's quite a weak volcano, and it has failed. Parts of the volcano have slid away in the form of gigantic landslides in the past. And that is the kind of thing that could occur, well, it will occur in the future, and it could occur without warnings.
I think it's important to emphasize to people and get across the idea that a sector collapse could happen without any warning. And it doesn't have to be steaming. There wouldn't be any precursor activity. This is a difficult message to get through because people like to see eruption effects.
A number of non-volcanic events could trigger a gigantic landslide, a large earthquake, which could happen at any time, a small steam explosion on the volcano. Even something as common as heavy, warm rains in the summer could melt the ice, weakening the volcano and causing part of it to slide away. Just by looking at the mountain, you can trace the path the melting snow and debris would follow down the valley.
These can be on a colossal scale. They can involve many cubic kilometers of material, and it can flow down valleys moving at freight train speeds, 40 or 50 or 60 miles an hour, and hundreds of feet thick. And I mean, this is a mixture of coarse debris, boulders the size of houses, moving in a water-saturated mixture, sort of like wet concrete, and it will literally destroy everything in its path by either burial or by picking it up and carrying it away.
The areas most at risk of being buried by a mudslide are large and heavily populated. Towns close to the mountain, like Orting and Enumclaw, both of which are growing in population. In the geologic past, landslides have even spread as far as Puyallup, Auburn, Kent, and Tacoma. A couple of large ones have even drained into Puget Sound at what is now Commencement Bay. And what has happened before could happen again. Up next, Mount St. Helens. Does this restless volcano still pose a threat to the Northwest? And a little later, taking the pulse of the Cascade Range.
You're watching Volcano Alert on Northwest Time Bomb on Northwest Cable News.
Snow-clad Mount St. Helens looks peaceful today, but when you look in this crater, you realize it wasn't too many years ago that this mountain wreaked havoc here in the Northwest.
It's a day many of us will always remember. On a sunny Sunday morning, St. Helens erupts, sending a plume of ash into the air. Hot mud gushes down the mountain and flows into the Toutle River. The mud flow completely rips houses off their foundations. Cows are left in the lurch. 57 people die. Entire forests are leveled. And geologists say this was actually a small eruption. 17 years later, the mountain is quiet, but the evidence is still fresh.
If you visit Mount St. Helens today, you can see graphic evidence of what a hot mud flow can do. It turned this beautiful river valley into what looks like an alien landscape.
Only little plants are poking up through the soil. Tree stumps surround the mountain. Many of us wonder if we'll live to see Mount St. Helens set off this kind of disaster again. Geologists just don't know. The mountain does have an explosive history. It's been the most active volcano in the Cascade Range.
We expect this thing to erupt again within 100 years. If it stays as small as that, then it won't be as powerful. There's not as much weight keeping everything in. But the longer it stays quiet, the more explosive it's going to be. Can I tell you whether this will be the next one? No, I can't say that. It's highly likely it is. But there are at least 3 or 4 other candidates in Oregon and Washington and California that could easily go before this one gets active again. It's just a matter of where the magma's coming at the moment.
Mount Baker in northwest Washington also poses a threat. Just a few months ago, steam was rising from the mountain. Geologists weren't too concerned. The steam vents have actually been around for years. But scientists say Mount Baker will erupt again. The question is when. Just a few weeks ago, a study predicted Mount Hood in Oregon has a 1 in 30 chance of erupting sometime in the next 30 years. And an often overlooked northwest volcano, Washington's Glacier Peak, has an active history. If it erupts, mud flows could head towards the towns of Darrington and Arlington, towns again with growing populations. And that is the main concern for scientists. People keep moving closer and closer to northwest volcanoes without being aware of the possible dangers. Geologists at the Cascades Volcano Observatory in Vancouver, Washington are working right now to inform people of those dangers. The observatory was originally established to monitor Mount St. Helens. It now covers all volcanic hazards in the western United States and has an international emergency response program. They maintain a cache of volcano monitoring equipment on permanent standby. So when a volcanic crisis occurs anywhere in the world, they're ready to leave immediately for the scene.
The domestic program sort of hinges off the international program because we do a lot of international responses. We kind of been dragging the domestic cache of equipment along.
This equipment is all custom made at the observatory.
This is one of the sensors right here. You can feel that there's a weight inside there, there's a mass, and then there's a coil of wire, and that generates a little electrical signal.
If the sensor picks up any activity in the volcano, it sends an electronic signal which causes spikes to appear on the instruments back at the observatory. The data gathered by the sensors are relayed here to the operations room.
From this room, scientists monitor all of the Cascade volcanoes around the clock. They look for signs of renewed life and readouts like this.
With the help of these instruments, scientists can locate earthquakes, determine if the volcano is changing shape, or see if there are any other changes taking place.
The U.S. Geological Survey operates another volcano monitoring station here at the University of Washington in Seattle.
The Volcano Systems Center is an umbrella title for a group of researchers from a diverse range of disciplines, working together to understand volcano systems. Researchers constantly monitor seismic activity in the Cascade Range.
The Pacific Northwest Seismograph Network is really the early warning system for any volcanic activity that begins to occur in the Cascades. We work with CVO in developing plans for all of the Cascade volcanoes so that when we do detect unusual activity that might be related to increased volcanic risk, we can activate very quickly.
With all the tools these scientists have at their disposal, with all the information they've gathered from volcanoes around the world, there are still many volcanic crises that they cannot predict.
The state of the art for volcano monitoring and eruption prediction right now is not that great. I mean, we can tell when volcanoes are restless, but we can't tell exactly when that restlessness may lead to an eruption, or even if it's going to lead to an eruption. You're sort of damned if you do and damned if you don't, you know. If you evacuate and an eruption doesn't occur, then you've got a real problem. And if you don't evacuate and an eruption occurs and people are killed, and you have a problem.
So the USGS is helping emergency managers and land use planners to have a better understanding of volcanic hazards.
We recently upgraded the USGS volcanic hazard assessment for Mount Rainier and have taken it to land use planners and public officials in the hopes that they will use it for planning purposes. I mean, it's much easier to avoid building a community or siting a community in a hazardous place than it is to move the community once you recognize the hazard.
But what if your community is already built and it's right in the middle of a volcanic hazard zone? Up next, one town that's preparing for the worst. And we'll show you how you can live knowledgeably and safely with volcanoes. It's noon in Orting, Washington, and this is a test of the emergency alert system. Orting citizens have grown accustomed to it. It's a daily reminder of their town's precarious location. 500 years ago, the electron mud flow raged down the Puyallup River, depositing mud and debris nearly 20 feet high throughout the valley that Orting now occupies. With its low cost of living and beautiful scenery, Orting is growing, and that increases the chance of a greater loss of life if a disaster occurs on the mountain.
What do you think about some of the geologists that say there may not be a half hour at the most?
And there's going to be a lot of damage then and a lot of lives lost, I think, if that actually happens.
Is this something you think about a lot, or do you not think about it at all?
We don't think about it.
Why not?
Because we don't think it's going to happen.
Rather stay here than be stabbed or shot. Just stand right here, right in the way of the mud flow.
But while some of the people aren't concerned, disaster officials are.
It's sort of become a panic type of a situation. We want people to understand that we want them to prepare and not scare.
Orting is preparing for a mud flow. But history shows us that mud flows can be caused by events on the mountain other than volcanic activity.
We've been told that the mud flows that have come through the area came through without any kind of warning. So that's the scenario that we've targeted.
If mud flows come racing down from Mount Rainier, hundreds of thousands of people will be in danger. So Pierce County management officials are hoping to install special mudslide detection systems.
We're working with the Geological Survey to see what we could produce for Mount Rainier that could be able to discriminate between just regular landslides, flows of winter floods and things like that, and a catastrophic mud flow that might affect life and property.
If you're concerned that you might live in an area at risk, the USGS can help.
We hope that they will obtain a copy of the hazard zonation map, that they will locate their homes, their kids' schools, their hospitals, and the other facilities, and find out whether they're in a hazard zone or not.
If you live in a volcano hazard zone, here's what you need to do. Contact the USGS to find out what risks your area is most vulnerable to. We'll give you the address at the end of the show. If your town has an emergency alert system, make sure you and your family recognize the alert and follow the disaster officials' instructions. If you're in the path of a mud flow, be prepared to head for higher ground.
You don't want to run away downstream, you want to run away up the valley sides in order to get above the level where mud flows will pass.
One of the best ways to learn about volcanoes is to actually visit one. Here at Mount St. Helens, there's 3 observatories, including this one that just opened at Johnston Ridge. It's only 5 miles from the crater.
Inside, you can watch the 1980 eruption as it's never been seen before in an exciting high-speed digital film. This interactive display tracks the path of the eruption.
You can get hands-on experience of volcano monitoring equipment
and find out what geologists have learned from Mount St. Helens. Outside, you can see what those exhibits portray. How in just 10 minutes, the eruption of Mount St. Helens transformed the landscape. The Forest Service's Peter Frenzen took us hiking along the eruption trail, where the volcano's path of destruction is still clearly visible.
But you can see that large standing trees were completely peeled back and shredded by the blast. One of the obvious questions that we ask in the exhibits in the center is, what happened to the rest of this tree? Well, it became part of the blast. It was literally picked apart by the flying rocks, and the shards of wood became incorporated into the blast, and they in turn helped fragment even more forest. It's very important here to take care to stay on the trails, because it's taken 17 years for the recovery to proceed to this point, and it won't take very many footsteps to erase 17 years of nature's handiwork.
Places like Johnston Ridge bring us closer to the awesome beauty and power of volcanoes.
You're watching Volcano Alert on Northwest Time Bomb on Northwest Cable News.
We hope you've learned something about Northwest volcanoes in our program. Now, there's no sign any of these volcanoes will erupt anytime soon, but it may not take an eruption. It may be a sudden mud flow. There may not be much warning. You should take the steps now to protect yourself and your family if you live in a volcano hazard area. The Northwest is the most beautiful part of the country, but we should respect nature. I'm Mike Clay. For all of us at Northwest Cable News that made this program possible, thank you for joining us.
For more information on volcanic hazards, contact the USGS at 5400 MacArthur Boulevard, Vancouver, Washington, 98661. Or try their internet address at http://vulcan.wr.usgs.gov.
In Xenia who say they were not warned had their life saved because they were actually getting 20 years of awareness and preparedness training through the media, and they knew what to do. They went outside. They were looking at the sky. 50 or 60 years ago, the idea of a tornado would have never occurred to them.
Amateurs shot film in both Xenia and Parker, Indiana during the '74 outbreak. The films proved pivotal in the growth of our body of knowledge about tornadoes. Photogrammetric studies of the films helped determine the wind speeds of tornadoes. Professor Fujita of the University of Chicago theorized that tornadoes often had multiple suction vortices surrounding the main circulation. The 1974 films proved his theory and proved that the multiple vortices do most of the tornado's damage. Those studies also showed Fujita that only about 10% of a violent tornado has winds of over 200 miles per hour.
But if you put that 10% of the path through a major city like Xenia, you're going to have death. There are people who, regardless of any warning, are not going to be prepared. They're going to be caught unawares, for some reason or other not knowing what's going on, and they're going to lose their life.
Our understanding of tornadoes exploded in the 1970s through photogrammetry, ground damage pattern surveys, and the development of Doppler radar. Dr. Fujita's F-scale standardized wind damage measurements for all researchers. Amateur tornado photography proliferated, and scientists from the National Severe Storms Laboratory armed themselves with motion picture cameras as proven research tools. In the 1990s, a new phase of research was to begin.
Good time to turn inside it, though, right?
Look at the debris it's beginning to pick up down the ground. Getting bigger.
That looks bigger than that when we seen this the first time, isn't it?
Not really. First time I ever seen one. You can even see it.
You've seen one.
Nah, I was under the bed. You can see it. Kicking. See all that debris?
You know, you would think, is it over there in that...
It's in that there housing development over there across Broadway.
In April of 1991, home video cameras all around Wichita and Andover, Kansas, recorded scenes like this. The popularity of home video has made tornado video downright commonplace. This sequence, shot by Mike Lloyd, is one of many of the Andover tornado.
Yeah, it's time to get in.
Too close for them.
Oh, look at the stuff flying.
Yeah.
Don't worry, Kath. I'll be down there real quick.
The storm's beautiful fury is almost more than an amateur videographer can resist.
Sitting right there. It's going to be here in just a minute.
You know it's dangerous. You know it can kill.
Kathy, downstairs right now.
And yet the picture in that viewfinder, the spectacle before you, is spellbinding.
Everybody stay in the house. Let's go right through that. Let's go right through that mobile home park.
Then the fascination can turn to horror.
Oh, God. Oh, God. Oh, God.
It went that way?
Yeah, it went right. Okay, it's gone right through. That's it. That's it.
This video of the same tornado was shot by meteorologist and storm chaser John Davies. This is the tornado that killed 17 people as it passed through South Wichita and Andover. Forecasters scored well on the Andover outbreak. Meteorologists at the Weather Channel were so confident of tornadic conditions, we flew a crew to Wichita 24 hours before the storm hit.
Well, in this particular situation, we had a very obvious tornadic potential, and the Wichita area was kind of in a 100-mile swath of, okay, somewhere in this area we're going to have a tornado, and we were just a little bit lucky in sending our crew exactly where a tornado hit. On any given tornado situation, it's more like about 50% accuracy on predicting the area in which a tornado might form.
Which is why Project Vortex was born. This armada of strange vehicles lined up in the parking lot at the National Severe Storms Lab are part of the largest tornado research project in history. Scientists from all over the country with portable Doppler radar and research airplanes and every kind of measuring device known to meteorology came to Norman, Oklahoma in the spring of 1994 to gather data and chase tornadoes.
And